Hello, everyone. I'm Dave Russell, owner of Dave Russell Media, based in Northwest Ohio. It is my pleasure to serve as the moderator for today's webinar. We want to thank Tiger-Sul Products and Farm Journal Media for putting on this webinar, and we also want to thank all of you for joining us. Before we get started, let me remind you that at any time during the webinar, you can ask questions by using the Ask a Question button at the top of the screen. Now, if you don't see the Ask a Question button, you are probably viewing the webinar in full screen mode. Just press the Escape key to see the button. When viewing the entire webinar, you will qualify to receive 1 CCA Continuing Education credit. How sulfur enhances the uptake and utilization of other nutrients, and understanding how sulfur reacts to the soil. Those are just a couple of topics we'll address in today's webinar. Tiger-Sul sulfur bentonite's influence on plant nutrient availability. Joining me on the webinar, Wesley Haun. Wes is an agronomist with Tiger-Sul Products. He conducts crop nutrition research, including sulfur bentonite applications. Wes's diverse agronomy background spans retail sales and consulting at the farm gate to technical agronomist at regional, national, and international levels. Also on the webinar, David Annis. David is a technical agronomist with Tiger-Sul Products, working with fellow agronomists, dealers, and farmers to help them manage their soil fertility and maximize profitability. David conducts research, trainings, and publishes newsletters and technical bulletins on applications of sulfur bentonite and micronutrients. Also on the webinar, BJ Harrington. BJ is the new marketing manager for Tiger-Sul Products, managing marketing efforts in the U.S. and Canada, as well as providing marketing support for Tiger-Sul's international operations. Gentlemen, welcome to the webinar. Wes, I believe you're going to kick things off. It's all yours.
Well, thank you, Mr. Russell. Appreciate the opportunity to join you today and share information on sulfur bentonite's influence on plant nutrient availability. And I've asked our technical agronomist, David Annis, to join me. And Dave will be asking questions throughout the presentation. And our attempt here is to answer those questions and provide details as we move throughout the presentation. Sulfur uses in crop production. There are 3 primary uses for sulfur. One is a plant nutrient, one is a soil amendment, and another is a plant fungicide. Today we'll focus primarily on the plant nutrient aspect of sulfur. There are a number of factors that influence crop production. These are a list of several of those in no particular order, those being sunlight, the weather, plant population, plant physiology, the nutrients, soil type, pests, genetics, and previous crop, and you probably have others you could add to that list. But today I'll focus on the nutrient aspect of these factors. I like to use the Liebig's law of minimum, and the concept here is the yield of a crop is reduced by the most limiting nutrient. By using this stave barrel concept, that barrel will only hold water to wherever that lowest broken stave exists. So if we use this same analogy in crop production and soil fertility management, the nutrient that's at the lowest level will be the most limiting to that crop. So the whole idea is manage this limiting nutrient and bring it up to optimum level. And then the next lowest nutrient will be most limiting. So we bring that one up to optimum level such that that crop has the potential to manifest itself in its greatest potential. Sulfur's role within the plant is many. Primary role is amino acids. Sulfur is a component of 2 amino acids, that's methionine and cysteine, and amino acids therefore are the building blocks for proteins. Sulfur is also involved in enzyme activity. It's also involved in the photosynthetic process, as well as the nitrogen fixation process within legumes. The impact of sulfur in plant nutrition, there are many interactions that take place, as well as conversions and metabolic pathways of sulfur compounds within the plant. And this schematic provides a little insight into that process. As sulfate is taken up by the plant, it is inactive. So within the plant metabolism process, it adds phosphate to that sulfur compound, and then is reduced and moved to the first amino acid is cysteine, and then further reduced to methionine. And notice all the sub-reactions that take place, which are critical in the synthesis of proteins themselves. And then sulfur is also involved in the nitrogen fixation process. This could be either a direct effect through the nodules and the microbes, or it could be indirect due to nitrogen deficiency in that plant due to the fact of inactivity by the microbes with a sulfur deficiency. And sulfur is also involved in the photosynthetic process. You know, if there's sulfur deficiency situations, the leaf chlorophyll concentration will decline, and you'll have degeneration of the chloroplast. The chloroplasts are the components that actually absorb sunlight and convert that sunlight energy into glucose. Then obviously if we have less photosynthesis taking place, then we've got less sugar within the leaf tissue. So nitrogen metabolism with sulfur deficiencies results in decreases in concentration of protein nitrogen. So when that happens, the plant tries to compensate for that to supply sulfur to the amino acids through protein synthesis, and those concentrations of non-protein, not protein nitrogen would be your nitrates and your amides.
Quick question, Wes. How do interactions between plant nutrients occur?
Interesting you asked that, David. And here again, as we look further into the interactions, knowing those interactions between plant nutrients is critical for us to maximize nutrient management strategies and also to enhance nutrient use efficiencies. So I'll try to explore that a little further. And looking at the first concept of interactions that take place is with soil pH. On the x-axis, we have a portion of the pH scale. And the whole idea is to look at these bars that represent each nutrient, and where the bar is the widest indicates the greatest availability. So the whole idea is look at all those nutrients, and where we have the widest bars across each nutrient, that falls between the pH of 6 and 7. If you go below pH 6, we notice that the primary and the secondary nutrients tend to decline in availability. We go above pH of 7, then we notice that the micronutrients tend to decline in availability. So here again, trying to maintain that pH in that optimum range of between 6 and 7 is the target to increase the availability of these various nutrients. This is one example of pH interaction in looking at phosphorus. On the x-axis, we have the pH, or portion of the pH scale. Then on the y-axis, we have the relative phosphorus fixation in the soil going from low up to very high. And if you'll notice, with a pH of, say, 4.5 and lower, we see a very high fixation of phosphorus with iron. Then if we move, that 4.5 up to approximately 6.5, we see a fixation due to aluminum with phosphorus. Then if we move above pH of 7, then we see a fixation that takes place with calcium. So where is the greatest availability of phosphorus? And you look at these humps and valleys, obviously in that pH of about 6.5 to 7.2 is where we're going to have the greatest range of availability for phosphorus. So as you can see, this is one example of the fixation that takes place with phosphorus as well as potentially with other nutrients as well. And charge balance. And yes, the soil has electrical charge, the nutrients have electrical charge, and at this root soil interface is where we have that first point of nutrient uptake and interaction that takes place. And unfortunately, these reactions take place beneath the soil surface, and if these reactions do not take place, then the crop is not able to absorb the nutrients it needs and does not manifest itself as well. So we'll take a deeper look at what's taking place below the soil surface. There's a charge balance that we have to work with, or the nutrients work with, and nutrients are taken up as ions, Some are positively charged and referred to as cations, and those that are negatively charged are referred to as anions. The nutrients that are cations include your calcium, your magnesium, ammonium, potassium, iron, manganese, and zinc. The negatively charged anions are your sulfate, your nitrate, your phosphate compounds, chlorine, borate, and molybdenum. So the discharge balance that occurs when the anions and the cations are in the uptake process, they lead to preferences by that plant. And when this happens, oftentimes we see either an antagonism or a synergism that occurs as that charge balance is obtained. Obviously, when the anions dominate the uptake process, then we have a reduction in the cations that can be taken up, or the reverse. If cations dominate, then we have a reduction in the anions being able to be taken up by the plant. This is a photograph of a root with root hairs on a barley plant. And notice those root hairs are very prolific, and actually they increase the surface area of that root such that it can have greater access to moisture as well as a wide range of plant nutrients that can be taken up. That area of where the root hairs exist is called the rhizosphere, and within that rhizosphere are mycorrhiza that actually lead to other interactions that take place within this rhizosphere zone. To help illustrate how this nutrient uptake takes place is roots absorb nutrients from the water film. We have a soil colloid, or you can refer to it as a soil particle. Soil particles have a negative charge, okay? And this water film that's illustrated here by the blue line, and this is actually microscopic in nature. So we have cations, which are positive charge, attracted to the negatively charged soil particles, okay? Some cations have two positives, some are one positive. So here again, if a two positive will take up two spaces on the negative, whereas a single positive will take up only one negative. So here again, you've got competing for sites on soil particles between the cations. But as a root hair protrudes into this water film zone, in order to take up a nutrient, it actually exudes an acid. Here again, releasing hydrogen. Hydrogen is positive charged. This positive charge then moves over and actually has a higher bonding strength than, say, potassium. So the potassium is released into the water film and then is able to be taken up by the root hair. There is suggestions that by adding sulfur bentonite product, which is elemental sulfur based, elemental sulfur must go through an oxidation process. That's the conversion of elemental sulfur to sulfate. In that reaction, sulfuric acid is released. And here again, by adding acid to this water film, potentially increase this reaction I've just described, here again, releasing more cations available for uptake by the root hairs. Now, obviously, the anions are negatively charged. They're repelled from the soil particles such that it's free floating here in the water film and available for uptake as well. Some factors that influence nutrient uptake. Here, all nutrient uptake rates are dependent upon specific interactions, whether that's the environment, the soil type, crop species, where if it's a variety or hybrids, or nutrient demand by a specific crop, or the management factors. And these are the factors that producers have more direct control of, that being plant density, soil fertility, availability to the plant or the crop, and then the planting date and integrated pest management procedures as well.
Can you be more specific about how nutrients react between each other?
I will certainly try to, David. And here again, as we go into this, it may seem a little more complicated, but there again, I'll try to keep it as simple as possible as we look at some of these interactions among various plants. But here again, those interactions among nutrients are part of the biological system. Those interactions can affect crop productivity as well as your return on investment. interactions occur with two or more nutrients. As indicated earlier, they can be positive, which are synergistic. It can be negative, antagonistic, or it can be no effect at all between those. So as we look at the positive, negative ones, they are equally important because of the ability to maximize the returns from positive interactions, but at the same time try to minimize the losses from any of the antagonistic effects that may occur. So as we look further at the nutrient interactions, this is Mutter's chart on various antagonistic and synergistic effects between plant nutrients. As we look around this circle, we see a wide range of nutrients listed. But look at the red lines, which represent the negative or antagonism effects between nutrients as compared to the synergistic effects by the green lines that you see between nutrients. But if we look at this list of nutrients, there's one that is missing, and that's sulfur. Why sulfur is not included in this chart, I'm not sure, but this is another chart that shows some mineral interactions, and yes, sulfur is on this one. There are primary nutrients listed here, there's secondaries, there's micronutrients, as well as the heavy metals. As you can see, there's a wide range of interactions between all of those. I'm not going to dive into those, but illustrate the point that when we look at sulfur, there are a wide range of lines here radiating out to different nutrient interactions. So here again, most of those fortunately are positive, but obviously some could be negative as well. So we'll stop and look at one interaction between two nutrients, and that being sulfur and nitrogen. Nitrogen is a primary nutrient, sulfur is a secondary nutrient. Of the 16 essential nutrients, these are the only two that require microbial activity to become plant available. In other words, urea, for example, being a nitrogen source, urea must be converted by microbial activity to either ammonium or nitrate to become plant available. Same way with sulfur. Elemental sulfur must be converted to sulphate before it becomes plant available, and this is with the assistance of microbial activity in the soil. Sulfur metabolism in plants is associated with nitrogen nutrition. Nitrogen metabolism is a function of the sulfur level within the plant. So here again, both supplement each other. So here's the results of a trial that Tiger-Sul conducted in 2015 through 2017. This is an average of 3 trials, 2 of which were in Ohio, 1 in Illinois, where we applied Tiger 90 at 30 pounds per acre of actual sulfur, and then the nitrogen rate was altered. And the first bar represents Tiger 90 with 160 pounds of nitrogen, which is the full rate, gave us a yield of 166 bushel. We put on nitrogen, phosphorus, potassium, the same over as we did over here with the full rate, except we reduced the nitrogen 20%. So only 128 pounds of nitrogen was applied with the sulfur, and we saw 167 bushel yield. Essentially the same yield there. Our Tiger zinc, 18%. This is our Tiger sulfur with zinc micronutrients added with full rate of nitrogen with 164 bushel. Reduced the nitrogen rate 20% and had 166 bushel. Tiger XP is our 85% sulfur product applied with phosphorus and potassium and the full rate of nitrogen at 160 pounds, give us 166 bushel yield. Tiger XP reduced the nitrogen rate by 20%, go at 165 bushel. So here again, as we look across all 3 products with sulfur, we saw no significant difference in yield when we reduced the nitrogen rate. Now, this is trial at 2 states, 3 locations, average. So here again, I'm not ready to say we can reduce the nitrogen rate and still add the sulfur and get the equivalent yield. But there's certainly a positive indication that you may want to take a look at on your farm and put in some on-farm trials to make that comparison, see if that works for you. Here's another trial looking at nitrogen and sulfur on canola. And this was conducted in 2000 by Jackson. I think this was in the state of Montana, putting on 4 different rates of nitrogen, going from 0 to 225 pounds in with no sulfur. And notice we didn't get no significant yield jump until we had the high rate of nitrogen. Then we used the same sulfur rates with 20 pounds of sulfur. And notice as you increase the nitrogen rate, we saw a gradual increase in the yield of canola. Then another trial was conducted where they used the same nitrogen rate, but they doubled the sulfur rate up to 40 pounds per acre. Then as you increase the nitrogen rate, you saw a gradual increase in the yield as well. But an interesting comparison here is the yield was basically the same with each increment of nitrogen rate between the 20-pound sulfur rate and the 40. So if I look at this, I'm probably going to say, okay, the more feasible application would be 150 pounds of nitrogen with 20 pounds of sulfur, giving us a 38 bushel per acre yield. So again, another indication of sulfur benefits nitrogen rates in even in canola production. Some other trials have been conducted, and I'll just provide some conclusions that were drawn from some of the other trials. A significant canola yield as well as protein content when the 11% increase with nitrogen and sulfur was applied. Nitrogen rate was rather high at 265 pounds to the acre with 45 pounds of sulfur. Conclusion here was there was an increase in pod formation and a decrease in pod abortions that took place, and with this certainly increased the benefit of the nitrogen and the sulfur synergistic effect. So Hugh and Sparks concluded that plant performance can be maximized by nitrogen application only if sulfur is adequate in pecan production, and that maximum response from the sulfur application can only occur if nitrogen is sufficient in the pecan production. And they evaluated the seedling growth, and the photosynthetic process was all a function of the nitrogen and the sulfur ratio in the leaf tissue. They concluded that the 9-to-1 ratio between nitrogen and sulfur was suggested to be the optimum for maximum growth. Now, this is the ratio of nitrogen to sulfur within the leaf tissue. This is not the ratio of actual fertilizer application to the crop. They concluded that the interaction of nitrogen and sulfur imposes stringent controls on the leaf nitrogen content as well as the sulfur content and the photosynthetic and growth of the plant. In another trial, Jansen, Nabati, and Femes concluded that nitrogen and sulfur nutrition was critical to optimum plant growth. The synergistic effects were beneficial at optimum rates. They were antagonistic when the rates were excessive, and concluded that sulfur is needed to increase the nitrogen use efficiency within the crop. As I mentioned earlier, sulfur is involved in the nitrogen fixation process, and here again, legumes obtain the majority of the nitrogen from the fixation process, and sulfur deficiency can result in decreases of nitrogen concentration with the plant if we have reduced fixation process within the plant. This trial concluded that sulfur deficiency in legumes is twofold. They stated that the reduction in crop yields also resulted in a reduced quality of the seeds, mainly because 2 amino acids that require sulfur were limited, those being methionine and cysteine.
Wes, you've demonstrated how sulfur has a significant influence in the nitrogen response. Can you tell us how sulfur affects other plant nutrients?
I'll certainly try, David. It does have interactive effects with others as well. Various research reports have demonstrated that sulfur influences the effectiveness of many of the essential nutrients. Those interactions can enhance or decrease crop response, either through growth and yield, or by altering the nutrient uptake and or utilization. Those oilseed crops tend to have the highest requirement for sulfur, followed by the pulse crops, the forages, tuber crops, and then the cereals. And when adding sulfur to nutrient management programs, we facilitate the uptake and the nutrient use efficiency of your nitrogen, your phosphorus, potassium, zinc. Zinc is the primary nutrient, has shown a response between the sulfur addition. Other work has been done with some of the other micronutrients with some inconsistencies based on reports of the published research. But here's a trial reflecting the sulfur influence on nutrient use efficiency in rice. This is actually an omissions trial. And on the y-axis, we have the yield of rice in bushels per acre. On the x-axis, we have different treatments. And in the first treatment, we have your nitrogen, phosphorus, potassium, plus sulfur, boron, and zinc, all added in this particular treatment. So what was done in this trial was they've taken the full treatment from treatment 1, eliminated the nitrogen component, and saw a 25 yield reduction in bushels per acre between 145 down to 120 bushels. Same thing with this treatment, where you had treatment 1 minus the phosphorus component and saw the same yield reduction as well. Then with the T1 minus K, as you had the full treatment minus the potassium and saw a yield reduction down to 116 bushels. And then in this treatment was minus the sulfur and saw an even lower reduction in yield down to 112 bushels. The zinc did not have as dramatic effect. It still dropped the yield 15 bushels down to 130. And then we take out the boron, we saw an even bigger drop down to 110 bushels. So what I did was took the data from this particular trial and converted the reductions in yield to percentages. So as you can see, that sulfur had a 23% reduction in yield, which is greater than either one of the primary nutrients, and only boron was slightly higher in the percentage yield reduction at 24%. Another trial using rice and looking at the influence of NPK as affected by sulfur with 4 different sulfur rates of application on the x-axis, and then the nutrient uptake in pounds per acre. Now this is uptake and not bushels per acre. And notice with the increase in the sulfur rate, with the blue representing the nitrogen, we see a gradual increase in the uptake rate when we increase the sulfur application rate. The red represents the phosphorus, and go from 0 application up to 18 pounds per acre of sulfur, we see a nice jump in uptake. But then again, between the 18 and 27 is basically the same uptake. But when we increase the sulfur rate to 36 pounds per acre, we see a nice increase of 84 pounds per acre of uptake of phosphorus. Then with potassium, which is represented by the green, between the 3 lower treatments, our application rates, we see essentially the same uptake until we put the higher rate of sulfur on. Then we see a much greater increase of up to 134 pounds per acre of uptake of potassium. So here again, a little different angle of looking at the uptake and the influence of sulfur on the primary nutrients. So yes, there are sulfur and phosphorus interactions. Those are a function of plant species, primarily due to the root morphology. There are synergistic effects between the sulfur and phosphorus on crop yield, and that has been documented for a number of other crops, including corn, wheat, sorghum, and canola. Due to the limited time today, I won't have time to dive into each one of those crops and the effect that they have, but here again, it certainly is beneficial.
Wes, are there other ways sulfur influences crop production or quality?
Oh, most definitely. And just to change the angle of the information I've been sharing with you today is looking at how sulfur influences the crop from a quality standpoint and flavor. Using onions and garlic, for example, they are in the allium family of plants. Those include the leeks, the shallots, and the chives. And these plants produce organosulfur compounds which react with the enzyme alliinase to give the alliums their distinctive flavor and odor. Interesting enough is that sulfur determines the pungency development in this group of plants. Increasing the nitrogen rate beyond the optimum level tends to decrease the allium content, whereas increasing the sulfur rate tend to increase the alliin content. Another angle to look at is the quality of wheat. And here again, sulfur can increase protein levels in the grain of wheat, and that in turn then influences the baking qualities of the wheat. In this diagram or the picture of two loaves of bread, the one on the left received wheat that had higher qualities of gluten protein, whereas the one on the right has lower quality gluten protein, therefore did not rise to the effect that the one with the higher gluten protein. The photo on the right is the end view of each loaf, obviously showing the higher gluten protein quality of wheat on the left versus the lower one on the right. So here again, yes, we can definitely see a difference in the quality of the wheat and the baking qualities as well. So ultimately, sharing this information today is ultimately to increase the crop response and maximize productivity and the economics as well. So the whole idea is look at how do we increase and obtain that maximum yield with the crop. So on the y-axis, we have a crop yield as percent of maximum. And then on the x-axis is increasing nutrient supply going from low on the left to high on the right. So obviously here in this first quadrant where the nutrient is going to be deficient, this is where we're going to see the greatest response from any fertilizer application. Notice we have a very rapid increase in crop response in this category. But as you see a gradual crop uptake of the nutrient, in this second quadrant, we still see an increase in the potential crop response. The thing we need to be aware of in this category is the crop does not detect a significant reduction or lack of nutrient uptake, so therefore deficiency symptoms are not displayed. As compared to this zone over here in the first quadrant, deficiency symptoms will be displayed by the crop. So the whole idea is make sure we have enough nutrients out there so we have optimum uptake so that the plant gives us a maximum response, and you see gradual increase in the uptake level, and that will continue over into the quadrant on the right. Even after the crop has maximized its response and it's declining, we see what we call luxury uptake. The uptake does not give you a response to the crop. So hopefully this has provided some input for you as to make better informed management decisions as it relates to soil fertility and including sulfur into your program. Granted, it is challenging to grasp and form a knowledge base of plant-nutrient interactions, but establishing a nutrient management program that enhances nutrient use efficiency will lead to advancement of agronomic crop production. But here again, sulfur does positively impact the yield of many crops. The key factor for this response is to make sure we apply sufficient amount of sulfur. Tiger-Sul has a portfolio of products to match most agronomic crop production requirements. So hope you'll give those considerations as you make plans for the upcoming cropping season. So with that, Mr. Russell, that concludes my portion of the presentation. I will return the controls back over to you.
Wes, you have certainly provided us with a lot of really good information here today. Now, we do have some questions that we will get to in just a moment, but first, let me remind those listening in, if you have a question, just hit the Ask a Question button at the top of the screen. Now, let me mention, too, that if we run out of time and don't get to your question, it will be answered by email within the next week. We're going to get to those questions here in just a moment, but right now I'd like to turn things over to BJ Harrington. BJ, it's all yours.
Thank you, Dave, and thanks to AgPro for providing this platform for us. Hello, everyone. Thank you for joining our webinar. It looks like we have a very large group today. My name is BJ Harrington. I'm the marketing manager for Tiger-Sul products for North America. I just want to briefly discuss a few points about our new marketing campaign, Ask for Tiger. A brief bit about our background. For decades, there was only one source for sulfur bentonite, and that source was Tiger-Sul products. When Tiger-Sul invented sulfur bentonite decades ago, there was much research and product development in the lab and in the field. There were a lot of listening to farmers, agronomists, retailers, and distributors. There was a lot of refining, testing, analyzing, retesting, and reanalyzing, all efforts to develop the most efficient sulfur fertilizer available. During the development process, we learned many things. We learned to develop manufacturing processes and the equipment, some of which were patented. We've also learned to develop methods of quality checking for consistent analysis and pastille size. We've learned to develop safe ways to manufacture, handle, and store sulfur bentonite. While Tiger-Sul is by far the leading manufacturer of sulfur bentonite fertilizers, some generic products are emerging in the marketplace. But in a recent survey, Tiger-Sul had a 98% name recognition in sulfur bentonite fertilizer market. The term Tiger 90 has become synonymous with sulfur bentonite, not only in North America, but all over the globe. When growers call a retailer to order Tiger 90, he may not always get Tiger-Sul Tiger 90 CR. Substandard products are being introduced with similar composition, but with many differences, such as inconsistent pastille size, uncertain quality control and analysis, poor pastille stability, meaning they're fragile or they break down easily, poor dust control, some are very dusty and can be unsafe, little or no field trial research, and an unproven delivery and availability record. We have multiple manufacturing facilities and keep supplies readily available. Tiger-Sul can get you the products where you need them, when you need them. When you trust us as your supplier of sulfur bentonite, you get local and global leadership. We have manufacturing operations in Alabama, California, Alberta, Canada, South Africa, and China. We have the largest support team in the industry, with knowledgeable team members strategically located throughout North America and the globe that are always available to help. We conduct extensive research and development. We have comprehensive programs with years of historical trial data, plus continuous ongoing field trials to support our product quality and performance and to assure a great return on investment for our customers. As a Tiger-Sul customer, you also get unparalleled customer service with prompt responses, modern order processing and tracking with on-time delivery standards. We build quality control into everything. Our in-house labs and quality control team ensure safety, product quality, and consistency. Tiger-Sul also embraces a culture of innovation. Our ability to innovate and consistently produce and supply products that deliver results is one of our greatest strengths. Tiger-Sul customers also receive access to the Tiger University, which houses online courses and resources for in-depth education on operations, safety, and Tiger-Sul products. We have a great grower-dealer support system, including password-protected library of documents to educate distributors, dealers, and growers on the benefits of applying sulfur bentonite. We are a manufacturing partner that listens. Tiger-Sul is an innovative company that listens to the voice of customers to produce the best products to fill their needs. Our customers can also trust us to provide operational expertise. We have decades of experience in agricultural manufacturing, producing nutrients products to address deficiencies that will result in higher return on investment. Also, Tiger is committed to Six Sigma operation disciplines to improve our manufacturing efficiencies. And we've built a trusted brand. Tiger-Sul has spent many years developing a trusted brand that farmers know. They trust the product that bears our logo to perform well in the field. They know it will be manufactured to the highest quality standards and deliver outstanding results. Our product line. We manufacture the best sulfur bentonite products in the industry. Tiger 90 CR is the industry standard 90% sulfur, 10% bentonite clay control release fertilizer. Tiger 85 is an 85% sulfur, which degrades quickly. Tiger 50 CR is a sulfur sulphate blend that provides a quick response and a long-lasting response. Tiger XP is composed of sulfur bentonite and a proprietary activator which produces higher sulfate release rates. Tiger Combo is ammonium sulfate and sulfur bentonite in one uniform-sized granule. Tiger micronutrients are made up of thousands of micron oxide particles per pastille encapsulated in a sulfur bentonite matrix. Tiger crop mixes are crop-specific micronutrient formulations with a custom analysis to provide optimal micronutrient ratios. Tiger turf mixes are sulfur sources and soil amendments to improve turf growth and water penetration. Now a little about our global campaign. Not all sulfur bentonite manufactured products are the same. From a leader in the industry for over 50 years, you want the most effective product with the best research and development, customer service, quality, and agronomic and educational support teams. To get the best, you must demand the best. So ask for Tiger by name and make sure you get Tiger-Sul products. And here's our territory map for the USA. These dedicated regional managers are ready and able to answer any questions you have about Tiger-Sul's sulfur bentonite fertilizers. And here's our regional managers for Canada who are equally qualified to help. Be sure to reach out to any of those in your area to learn about your local crops and provide solutions. For more information, you can visit our website, which has information about our products. You can learn from our Tiger University portal, and you can get contact information to reach out to us directly. Also, look for us on social media. And thank you for spending a little time out of your busy day with us. Again, my name is B.J. Harrington, Marketing Manager with Tiger-Sul Products. So that wraps up my portion. Back to you, Dave. Thank you.
All right, BJ. Well, thank you. Gentlemen, you have, again, provided us with a lot of really good information. We do have some questions that we're going to get to in just a moment, but first, let me remind those listening in, if you have a question, just hit the Ask a Question button at the top of the screen. Wes, let's get to the questions. Our first one, how does sulfur increase nitrogen utilization?
Well, that's a good question, Dave, and certainly, as we talked about in the presentation, it's actually twofold. You know, we look at increasing the uptake potential by the addition of sulfur, creating that acid zone within the microfilm or the water or moisture zone around that soil particle and increasing the uptake potential of the nutrients. But once we get into the plant, that sulfur, as I mentioned earlier in the schematic, we activate that sulfur with adding the phosphorus and then all the secondary reactions that take place and the reduction of the sulfate to amino acids being cysteine and methionine, and then ultimately into the protein. So we increase the protein activity, therefore being able to activate and increase the nitrogen utilization as both the sulfur and nitrogen are involved in the proteins as well. So hopefully it gives a brief outline of how that takes place.
Well, if I recall correctly, you mentioned mycorrhiza when talking about root hairs. What is mycorrhiza?
Good question, and I probably should answer that more specifically when I gave the presentation. If you recall the photograph and all the little root hairs, the mycorrhiza are actually fungi that infect those root hairs. And they put out little Philip hyphae, which are little finger-like projections that increase the surface area over and above what the root hairs do. So it facilitates the uptake of moisture as well as nutrients in addition to what the root hairs do. So here again, it's a symbiotic relationship there as well between the mycorrhiza and the root hairs in the plant.
Well, once again, if you have a question, you can just use the Ask a Question button. Wes, we're getting some really good questions in. Another one that just popped up, are all plant nutrients absorbed by plants at the same time?
Excellent question. And the short answer is no, but to give you more specifics on that, actually the uptake is determined by plant demand. So if there's a nutrient in high demand, it's going to get priority in the uptake process, but some nutrients can be taken up simultaneously, but no, not all at one time, that's for sure.
So does sulfur influence micronutrient uptake?
Oh, yes, it does. Unfortunately, there's been limited research in looking at micronutrients and the sulfur interaction, but as I gleaned through some of the published work, zinc seemed to be the most consistent, in response to sulfur. There's work been done with copper, iron, and manganese that's been evaluated, but somewhat less consistent. So don't put as much emphasis on that until we see more consistent data.
So how much sulfur needs to be applied to obtain these results?
Wow, that can be wide-ranging. It's actually dependent upon the crop and its demand for sulfur. Here again, some crops have a high demand, such as the oilseed crops, as compared to some other crops. Vineyards, grapes don't need near as much as some of the agronomic crops do. But for example, I use 0.18 pounds of sulfur for each bushel of corn that you anticipate harvesting. So here again, I use the uptake needs for sulfur rather than removal rates to make a recommendation.
Once again, if anyone has a question, just use the Ask a Question button. Well, since Tiger Products increases nitrogen use efficiency, does that mean the farmers can use less nitrogen on their crops?
Well, there's recent research that we at Tiger-Sul have conducted seeing some synergistic effects between nitrogen and sulfur, but I'm not ready to say that you can reduce your nitrogen rates when you add sulfur and get the same yield. But certainly we're seeing some positive indications that that could be true.
Well, I'll tell you, Wes, I'm impressed by the questions coming in. This one I like. Will application of sulfur to my crops reduce the soil pH?
Well, that could go multiple directions. Possibly, probably, maybe, and maybe not. But depending upon how much you apply, by generally speaking, applying sulfur as a plant nutrient, we're only putting on 20, 30, maybe 50 pounds to the acre. So that's probably not enough to really offset the buffering capacity that the soil may have in reducing the pH. So I don't get too concerned about that, because when we add sulfur as a soil amendment, we're needing to apply, say, 300 or so pounds on a real sandy soil up to 1,500 pounds to the acre on a high clay content soil to lower the pH 1 point. So with that in mind, with the low rates we're applying for a nutrient status, I would anticipate very little effect on pH, if any.
So what's the best way to determine if I need to apply sulfur?
Well, we highly recommend that you do a soil test in conjunction with plant tissue analysis. Soil testing is not the most consistent or reliable method, but when we put soil testing in combination with a tissue analysis, we can see what's actually in the plant being taken up, and then compare the two to make some assessments on the needs for sulfur. And then also, consider previous cropping history and yield potential, and those factors must be evaluated at the same time.
Gentlemen, we have run out of time. For those that did not get their questions answered today, again, it will be answered by email within the next week. Let me once again thank Wesley Haun, an agronomist with Tiger-Sul Products, David Annis, technical agronomist with Tiger-Sul, and B.J. Harrington, marketing manager for Tiger-Sul. I would also like to thank Tiger-Sul Products for their support in bringing this information to our audience, and certainly thanks to Farm Journal Media and to you for being a part of today's webinar. I'm Dave Russell.